right, good morning. Welcome everybody. My name is Dirk Sykora. I'm a business development manager within Lawo, specifically for media infrastructure. So I would say the IP-based solutions that we provide. Today I'm going to talk a little bit about the global events and how IP workflows were being used on these global events. So I believe we all know that last summer was a pretty busy summer. We had two large sport events, one in France, one in Germany. Given the limited time, 20 minutes, I'm going to focus on the event in Germany where we were watching the football tournament. However, the technology used on both events were quite similar. So just to dive into a bit of a quick high-level overview, I'm going to fly pretty high-level helicopter overview over what we were actually doing. First of all, in Germany, we had 10 venues. With a central IBC, several production teams were being used on all the different hubs to produce the content. All the video content was produced locally in the stadiums in 1080p HDR, and all the audio content was produced in three formats: immersive 5.1.4, surround 5.1, stereo, and last but not least, in every stadium there were up to 150 commentary positions being used. So very quickly, there is a bit of delay on my clicker. Just a high-level overview. Every match was being recorded with a minimum of 33 cameras. From the quarterfinal moving forward, we had 46 cameras and a combination of different types of cameras, of course. On the audio side of things, we were using 56 microphones to produce the international mix. And this was a combination of ORTF microphones, field of play microphones, wireless microphones, camera mics, and so on. Now, from every venue, there was actually a full redundant network connection to the International Broadcast Center in Leipzig. This was handled with full redundant dual 200 gig network pipes. So in total there was 400 gig of bandwidth available, being split over a red and a blue network, each providing up to 200 gig of network connectivity. This network was used for all the transport of all the signals: audio signals, video signals, multilateral feeds, unilateral feeds. I have to point out there was a bit of a difference between the tournament in Germany, where all the video signals were transmitted uncompressed, where we provided in France a different type of solutions, where the video signal transport was done based on JPEG-XS. But again, I'm going to focus on the tournament in Germany. So all the signals were then being transported to the International Broadcast Center. For the people that don't really know what it is, this is like the temporary hub where all of the broadcasters are being located, all of the right holders are being located. There's a lot of activity actually happening there in that broadcast center. Within the broadcast center, we have the master control room. So the master control room is the space or the place where all of the signals are being received, are being monitored, and are being distributed. So within that master control room, all of the live stadium feeds, the camera feeds, individual camera feeds, the different program feeds like the team player A, team player B feeds are being received. All of the unilateral feeds are being received. And what is really important to understand is that there is a multi-feed approach. And what do I mean with that? Within that within the MCR, people are using 1080p HDR content, but also monitoring 1080p SDR content and 1080i. So that's important to understand. I'll come back on that. Next to the master control room, there is like the quality control room. This is not really like the technical center, it's more like productional. So these people are in touch with the production teams on site and they are actually monitoring, let's say, the quality and the consistency of the international feed being created. Then the next room is like the audio control room. So this year there were two immersive audio control rooms being built in the IBC, and also in these rooms every game was being mixed full in immersive audio. So locally on the stadium side there was the 5.1 and the stereo mix. However, in the IBC there was the immersive audio mix. So here in this room they were actually doing the live mix from every game. Last but not least, there is also the transmission and the distribution. So from the IBC, all of the signals that are being received from the venues are then being redistributed to the whole world. And this is done based on three key pillars: network, file-based content, and satellite feeds. So you can actually see here, and later on you can review the slides, you can see how this was done in detail. Now, how was IP the key to build a successful project? I'm going to dive a bit now more into technical details. So first of all, we delivered a whole solution where we provided connectivity, where we provided processing, where we provided a management and control system, and of course the human interfaces, touchscreens to operate the whole system, fader panels to do an audio mix, and so on and so on. If we look at the solution here, which was fully based on IP, we start with the physical I/O. Physical I/O actually, where we used a full IP-based system to connect all of the signals from the venues back to the IBC. So, as already explained, we had a full redundant 200 gig pipe. Over those pipes, we transmitted all of the audio and video signals and the metadata signals based on 702110. So we had 10 venues, one large network. It was fully NMOS controlled, based on 702110. Now, to dive a bit more into technical details, you actually see here like a small picture from the kits in the venues. So this kit was actually built out of a full redundant Arista network, being connected to the dual redundant 200 gig pipes. There was, apart from the Arista network, there was a full redundant Cisco network for the management and control. So there was even, the design was fully based in a full redundant path, both on streaming and on control. Then in the flight cases, locally in the venue, we had a full redundant Meinberg P2P master clock system. So this means that the network could provide P2P transport, that was no problem, but if there would ever be an issue with clock distribution, then it was even decided to have a full redundant Meinberg P2P master clock on site, connected via GPS or synchronized via GPS. And of course, we were then from Lawo providing all of the .edge gateways, which is like a very high density solution. In a single frame, we could actually connect up to 192 SDI connections. The whole system was even battery powered, so if the whole stadium, if the whole venue would go down, the system would still continue to work. Now, apart from that, within the IBC, we also provided all of the SDI gateway functionality, fully based on IP again. So for the users in the IBC, they didn't really have like a difference in operational mode between the signals locally handled in IBC or the signals coming from the venue. For them, it was actually one large I would say video and audio router, so they could just route any signal from anywhere to anywhere. So for them it was like a router experience where they had like a combination of the distributed signals and the local signals in the IBC. Just keeping an eye on the time. We're 8 minutes in the presentation. So the processing this year, and that I would say was for the very first time done on a large scale event, was fully based on IP-based workflows, however, not using physical devices. This means we were using a server-based platform to provide both audio and video processing. This server-based platform was actually providing a solution where we decoupled the software from the hardware. What does this mean? That there was no specific device to provide software function 1, another device to provide software function 2, another device to provide software function 3. So we actually had one generic platform where we did both audio and video processing within the same server-based platform. Just important to note is that the technology that we deployed there is using fully cloud-based technology. So this means that you can deploy this technology locally on-prem, but you can also run it, for example, somewhere in AWS or in any other cloud-based facility provider. Now, let's take a quick look a bit more in detail what we actually did. You actually see here a picture from the technical center in the IBC, where we installed a central cluster of servers. You can see we had a total of 20 servers providing this audio and video processing, every server connected to the same streaming network, the Arista network, and we had a 100 gig connection, full main and redundant, going to every server. So all of this technology was using just standard Dell servers, but very frank, you can run it again on any type of server. What did we actually do? Every transmission path as a start was processed within these servers. We had 274 outgoing transmission paths within the IBC. Now, why did we need this processing? First of all the feeds coming from the stadium were produced in 1080p HDR, because that was the standard set by the organization to do the video recording. However, we all know that a lot of right holders are using 1080p SDR or even 1080i. A lot of right holders are not transmitting in 1080p HDR. So this means that every feed coming from a venue was going in this stack of servers and was being then converted from HDR to SDR. So we had like HDR SDR processing, color correction, and on top of that we also did interlacing to provide an output based on 1080i. So we had within this stack of servers both HDR SDR processing, interlacing. We did up conversion to UHD as well. Some of the right holders were expecting UHD content. However, the production was in 1080p. And then for the return feeds, we did a couple of down conversions as well. Apart from the UDX, we also provided stream transcoding. To be very transparent, this was not done in Germany. This was done in France. Because I explained in the beginning that in France, the network connectivity to the venues was done, or the signal transport was based on JPEG-XS. So in France, we provided stream transcoding, also based on server-based technology, where we were receiving the JPEG-XS streams coming from the stadium and in the IBC converting them to 2110. The other way around as well. We received 2110 streams uncompressed in the IBC and we were redistributing them to the venues based in JPEG-XS. So, next one was the multi-viewer. Once all of these signals were being transmitted into the MCR, into the IBC, they had to be monitored. And all of the multi-viewers were also based on a full IP-based Lawo solution, providing the monitoring for all the incoming and all the outgoing signals. Next, we had the immersive audio mixing rooms. I already explained in the beginning that locally in the IBC there were 2 immersive audio mix rooms, which were also receiving over the same redundant network all of the audio signals from the venues. So every single microphone was being transmitted to the IBC over the same network using SMPTE 2110, or you could say AES67. And every single microphone was then being mixed locally here in the IBC. The mixing console is just like a remote control panel. I would say it's like your mouse and keyboard. You actually remote control a DSP, which again was running in your network as an application running there. Next one was the commentary. I explained in the beginning of the story that within every venue there was a maximum of 150 commentary feeds. Now, over all the venues, spread over all the venues, we actually installed 500 commentary positions, and they were then, depending on the game, moved from one stadium to another one. What is important to know is that these commentary positions were locally controlled in the CCR, which is the commentary control room, but the central processing was done in the IBC. So this means that every audio signal from the commentary positions, again over the same network, was being transported to the IBC. And if we look at the next slide, you can see that all of this audio processing in the IBC was again being pushed into this stack of servers, where we had 240 audio processing channels doing all of the detailed audio processing and even the delay to resynchronize with the video within the same platform. So think that on this whole server stack, we did all the video processing, but also all the audio processing combined within the same server-based platform. So Last but not least, such a system needs a proper system management. A proper system management because users will not dive into IP, deep IT technology. They need like a proper interface to control of this. And we actually did this with our home and VSM-based platform. We actually had a dedicated team on site making sure that all the users had a right control panel with all the buttons and all the requirements that they needed. So what is the summary? I would say for me, the takeaway from last summer was that for the very first time, we deployed a full IP-based solution, but not with dedicated hardware, but actually based on a server-based platform. So we see actually a transformation going from dedicated hardware into a server-based platform. I would say, therefore, you get an agnostic platform, like an infrastructure agnostic platform, where multiple functionalities can be combined within the same platform again. You get a full flexibility and agility. And I want to point out very quickly about the flexibility. This whole server stack was originally planned for the video processing. And it was only when we were on site that the customer came to us and said, well, we actually need to have a possibility to delay all of the commentary audio feeds. And there it was decided actually on premise to also spin up all the audio processing. And this was possible because we actually provided a solution which could do any of that processing. Again, what is important as well is the multiple formats. Think about the JPEG XS, the 2110, but you could also combine it with NDI, SRT, even Dante. All of these formats running within the same platform. I would say, therefore, we reduce the need for proprietary hardware. And the final bullet point is where I see it going, where we as a company see it going, is that we are not going to use a dedicated server stack only for one vendor, but that we're going to combine solutions from multiple vendors within the same server platform. Yeah, that is actually, I would say, today, this is still like every vendor is using its own server stack. How we see moving it forward is that you as a customer will combine it within the same server stack, so that you really have a server-based platform where you can have solutions from multi-vendor approaches running in the same platform. That was it from my side. 18 minutes, so I would say